Hello my dear students, in this lecture we are going to see one previous year GATE numerical. This question was asked in GATE 2021 and this question is based on conduction, convection, heat transfer through a slab. So let us understand the question. The question is, ambient air flows over a heated slab having flat top surface at y is equal to 0. Let us say this is a slab, right? Flat slab. Over this slab the ambient air is flowing. So my dear students, here we can say the air is flowing over the surface like this. And my dear students, here let us say on the surface y is equal to 0. Y is equal to 0. Then the local temperature in Kelvin profile within the thermal boundary layer is given by. Now there will be a thermal boundary layer. Let us say the thermal boundary layer forms like this, right? And within this thermal boundary layer, this is the thermal boundary layer thickness, right? And this line is called thermal boundary layer. Now within this thermal boundary layer, the temperature profile in air, let us say here there is a air is flowing, and in this air they have given temperature profile, which is temperature along y direction is equal to 300 plus 200 exponential power minus 5y. Therefore temperature profile is given 300 plus 200 exponential power minus 5y, right? Where y is the distance measured from the slab surface in meter. Now from this slab surface we are measuring y, means on this slab surface y is equal to 0 already we have written. If the thermal conductivity of air is 1 watt per meter Kelvin and that of slab is 100 watt per meter Kelvin, right? Now here thermal conductivity of air is given, which is 1 watt per meter Kelvin, and thermal conductivity of slab material is given, which is nothing but 100 watt per meter Kelvin. Then the magnitude of temperature gradient dt by dy within the slab at y is equal to 0 is. Now my dear students, they are asking temperature gradient dt by dy, but they are asking in slab. Whenever y is equal to 0 is question mark in Kelvin per meter. Now they are mentioning again round off to the nearest integer. Now my dear students, let us observe the phenomenon of heat transfer here, right? Now between air and this slab, right, let us say this air will be having some temperature T infinity, temperature of air is T infinity, right? And this slab wall temperature, let us say here wall temperature is T wall. Now my dear students, between this air and slab there will be a convection heat transfer. But my dear students, between the first layer of air, let us say this is the first layer of air I am showing with red color. Between this first layer of air and slab there will be a conduction because of no slip condition. As this air is under no slip condition, the fluid in contact with solid surface is under no slip condition, therefore there will be a perfect conduction, means there will be a conduction in air, and again at the same location there will be a conduction in slab also, means there is a conduction in air at this very small location I am saying. On topmost point there is a conduction in air, and on bottom there is a conduction in slab, right? And apart from this, as I go apart from the slab there will be a convection, right? And my dear students, for steady state condition, we can say for steady state the convection, heat transfer by convection is equal to heat transfer by conduction in air is equal to heat transfer by conduction in slab, right? This we can say for steady state condition at each and every location heat transfer is same, right? So my dear students, if I equate the other two equations, that is conduction in air at y is equal to 0, but here conduction in air will be at y is equal to 0, right? Definitely at y is equal to 0 there will be a conduction, right? At y is equal to some distance there will be a convection, and at y is equal to 0 means first layer of the fluid in contact with this slab there is a conduction in air, and as well as at y is equal to 0 there is a conduction in slab also. Let us equate these two equations. Conduction in air is equal to conduction in slab, right? Now my dear students, we know that the Fourier law of conduction, as per Fourier law of conduction, the conduction heat transfer is nothing but minus Ka dt by dx or dt by dy over here, right? In this case, as heat transfer is along y direction, here we can write dt by dy. This is as per Fourier law of conduction. Therefore, this conduction in air must be equal to minus Ka dt by dy in slab. at y is equal to 0. We can say at y is equal to 0, right? Now let us put the values. Now for conduction, the same area is available for both. Let us see the area. If I observe the area available for conduction, here you will find this area. Let us say this area, right? This top area is available for conduction in both. That is, this area is perpendicular to the direction of heat flow, and the perpendicular to the direction of heat flow is nothing but that area we are considering for conduction. Therefore for both case area is same, therefore from both side area will get cancelled, right? Therefore here we can say minus minus sign will get cancelled. Therefore thermal conductivity of air into dt by dy of air at y is equal to 0 of air at y is equal to 0 is equal to thermal conductivity of slab into dt by dy of slab at y is equal to 0 of slab at y is equal to 0, right? So let us find this. Let us put the values and let us find this calculation. So my dear students, here thermal conductivity of air and slab is given, and dt by dy of slab at y is equal to 0 need to be calculated. And here dt by dy of air at y is equal to 0 we have to calculate from the temperature equation. The temperature equation they have given. Let us differentiate this equation. You will get dt by dy in the air, right? So my dear students, let us put the values over here. If I put values, right, let us put the values. Therefore what will be the equation, right? Here the equation will become thermal conductivity of air is 1 into d dy of air. Temperature of air is 300 plus 200 e to the power minus 5y, right? At y is equal to 0, and later we have to put y is equal to 0 is equal to thermal conductivity of slab is 100 into dt by dy of slab at y is equal to 0, which is a question, which is the question in this, right, topic. So let us find this. So here everything we have written. So my dear students, let us differentiate this equation. So my dear students, we will get here derivative of constant will be 0, therefore derivative of 300 will be 0, plus now here 200 is constant, therefore 200. Now derivative of e to the power minus 5y will be minus 5 into e to the power minus 5y. It will be minus 5 into e to the power minus 5y, right, is equal to 100 into dt by dy at y is equal to 0, right, in the slab. Now my dear students, here we have to put at y is equal to 0, at y is equal to 0. So let us put the value of y as 0. So the equation becomes here minus 5 into 200 into e to the power 0 is equal to 100 into dt by dy, right? So my dear students, here dt by dy in the slab at y is equal to 0, because we have kept y is equal to 0, will be equal to e to the power 0 is 1, e to the power 0 will be 1, it will become minus 10, right, Kelvin per watt. My dear students, if you type here minus 10, you will get 0 marks, because they have asked what is the magnitude of temperature gradient. Now my dear students, what is the meaning of magnitude? Magnitude is never negative. Therefore we can say the magnitude of dt by dy, the magnitude of dt by dy in the slab at y is equal to 0 will be equal to magnitude of minus 10, which is equal to 10, right? The magnitude of minus 10, minus is magnitude is never negative, therefore it is 10 watt Kelvin per meter, right? So my dear students, here in the fill in the blanks you have to type 10, then only you will get full 2 marks. Otherwise for minus answer you will get 0 marks, because they are asking magnitude. And if this magnitude word is removed in the from the question, then you have to type minus 10. I think you are getting this point. Thank you dear students. In next lecture we will see one more numerical on this topic which was asked in previous year GATE examination.